Hello and welcome back to the lab. Today on the bench we have a 3326A 2-channel synthesizer from HP. I was not intending to film a video on this. I was hoping I could just whip a repair out and get this up and running for the lab. I did not want to bore you guys with yet another function generator repair video because I've done I've done quite a few recently actually. At least it feels that way. So I was gonna smash this one out and get it all prepped and useful for the lab. But what I've run into is interesting enough for me to turn the camera on and record a video. So I am bringing you guys in mid-repair. Typically I do not do this on the channel. For those that are just discovering the channel, you guys find out about this stuff as I do. I don't do any pre-work on anything. I might read a little bit of a service manual just to find out where like power supply rails are and things like that for troubleshooting. But you guys see the troubleshooting process in real time as we're going through it. And I do think that's a little important to convey. So that's the way we do things around here. Nothing scripted. So sometimes I have some pauses and things like that. That's because nothing's scripted and we're doing this in real time. So I may have to shut up and let the brain catch up, but that's what we're doing. Through the magic of editing, we edit a lot of those out, but that's some of the what's going on behind the scenes. Let's get into this thing. So this thing is throwing a intermittent fault when you start it up of a 193 and 194. Both of those faults are DC offset issues. So I was hoping it was going to be as simple as the 8165, get it up and going, maybe find a diode, you know, nothing too major. Nope. In diving into the service manual and starting the troubleshooting process, you guys will notice that the DMM's on up here. What you can't see is the 7.5 digit DMM is down there. That is because the power supply in this particular unit is incredibly tight tolerances. On my plus and minus 15 volt rails on this power supply, I have a voltage tolerance of 10 millivolts and 20 millivolts respectively. So 10 millivolts on the plus 15, 20 millivolts on the minus 15. But they're spec'd to a ripple of 50 microvolts, which is an incredibly tight tolerance. Like tech scopes aren't even that tight for tolerance. They have ripple in the millivolts. This thing has ripple in the microvolts. Doing some ripple measurements, and that's one of the reasons why the 7510 is on, is actually measuring that level of ripple is incredibly difficult. And I was stretching, wasn't really stressing it, but I was stretching the 6500 to its limits, and I needed the extra precision that I got out of the better reference in the 7510. But I found out my ripple was out of spec. So the supplies are running about 130 microvolts of ripple. Wouldn't seem like too much, but the other thing is doing the self-test, which is shift DBV6. All the self-tests pass. So all the boards are doing what they're supposed to do. Everything's functioning the way it's supposed to function. It just fails that DC calibration when it's booting up, and when you do a manual cal by hitting this button right here, it'll go through a cal step and work on that. So given that I was thinking about that, and the ripple's a little high on the power supply rails, not awful, but a little high, double spec, I was kind of getting into the realm of maybe recapping the power supply, and that brings us up to where we are right now. I've got the power board almost out, and I had to take the bottom off to get the power board out, and let me show you the carnage that I have found. We have quite a large transformer for a very quiet linear supply, and then back here is the power board on this unit. There's a hold down right here that you have to pull 2 screws out to get the power board out, but then the power board just pops out bottom and top, and the whole board will slide out this way. There's a little bit you have to do over here with these caps. There's a screw that needs to be taken off, and then there's some pins that hold these cups on for these capacitors on the back. And then the power board just comes off the main board at the bottom. So if we pop this out, like so, we'll have to flex this out of the way a little bit, but our power board will come out. And this is it. We have pass elements on the top, filtering caps on the bottom, some more filtering caps down here. And everything looked pretty good. Not too much problems there or anything like that. But, oh, we have some carnage, and it gets so much worse. These were latex spacer pads. I have some here, I have some here, I have some here. This has dripped down and covered the entire bottom side of the board. Actually, this cap got a little hot. Or no, oh, that's a regulator. Okay, so we'll check that. This got a little warm. But it's a linear power supply, so it does burn some power. But if I shine a flashlight in here, oh, it's so bad. Let me get a light. You guys can see all this gray. All of this gray down here is going to need to be cleaned up. That's all latex. Oh. It gets even worse. I had to take the bottom off. This is the transformer. This right here is a transformer plug that sits on the bottom of the unit. And in pulling the bottom cover off, more. So I think I found my problem, and I found my fault. I'm going to have to clean all of this before we do anything, because I'm sure, especially with my tolerance of microvolts, this is conductive. It's messing with stuff. So all of this stuff's going to have to come off. Hopefully alcohol actually touches it and comes off. Here's the back bottom panel. We'll have to clean this off too. I can be much more aggressive on here. We can use some acetone and stuff like that on here. But I'm in for some deep cleaning. So in a previous life, I actually did some animatronics work. And we had latex masks for the characters. Latex rubber is only good for about 11 years before it starts dripping, liquefying, and getting everywhere. It's just one of the drawbacks of the materials. Makes great temporary stuff, but it does not have staying power. It will get everywhere. The location where we did some animatronics was mildly horror themed. So the fact that the characters' faces started dripping after 12 years wasn't necessarily a bad thing. It just added to the theming. But latex does not withstand the test of time. And this is tacky and everything like that, so I am pretty sure that is natural latex rubber. So I'm going to get to cleaning and go from there, because I can't do any troubleshooting, especially when we're talking about signals this low, until this is fixed. All right, good news and bad news. Good news is 99% alcohol is touching it. It is cleaning off. It's just going to be a wildly tedious process of getting all of this stuff mechanically removed without damaging the board, and then doing the main board on the other unit and getting it through there. So I'm going to work on getting this cleaned off, and then I'll bring you guys back. This is one of those jobs where you just turn on some music, get in a zone, and work through it, because it's about all you can do. All right, well, I am not unhappy with the way this is cleaning up. Isopropyl alcohol is pulling it off without too much trouble. I don't really need to use anything more aggressive. To get the pads off, I popped a layer off. The adhesive part of it, not the rubber part of it, but the adhesive, it actually held together, so I was able to pull up a corner and then just pull it off with a pair of pliers to get it off the board. Lots of Q-tips, lots of alcohol, paper towels to just mechanically remove all of this stuff, solvent to break it up, and then get it mechanically removed. But the good news is, unlike capacitor electrolyte, it did not eat into any of the traces or anything like that, so it kind of just stayed on the surface and the solder mask protected everything. So yeah, kind of a pain to clean up, but also it could be way worse. It could be capacitor electrolyte that it ate the whole bottom side of the board, so I guess it's a trade-off. Okay, to clean up the bottom side, we'll pull one of these pads off here real quick, but as you can also see, I have the unit propped up and I have a negative tilt. The reason I'm doing that is I don't want the goop or solvent to run into the card cages. I'm already going to have to check some of what's in the card caddies for latex resin, but I don't want to have more cleanup than I need to, so I didn't want to flush it in there with the solvent. So I wanted it so it's tilted back towards me, so gravity is pulling it down to the bottom of the board. And we're getting, and see the latex is gone. This is that black sill pad that's at the bottom. And all I want to do is just get this edge up. Just a little bit, that's enough. Now we'll come in with a pair of cutters. Don't squeeze too hard. Pull it up a bit more. Now a pair of needle nose. And off this will come the rest of the way. Just like that. So I didn't want any of this stuff falling in these vent holes. So we're cleaning it with a negative tilt, and I'm being extremely careful not to have it fall on me. But this is letting us get in there more alcohol. Alcohol's softening it up, but as soon as the alcohol goes away, it turns into goo again. And we'll get in there and clean all this crap out of here. There's a lot of reference stuff and everything underneath here, so this wasn't shorting out any power supply rails. God knows it could have if it had been conductive. But with the extremely low currents and microvolts of ripple that this unit is spec'd for, it could have easily been leakage paths enough to where it was causing our problem. Definitely got to take care of this before we do anything else. This is a plastic tool, so if I slip, it's just going to skate across the solder mask. It won't gouge anything up. But God, this is gross. Ugh. Nope, we'll have to get that one off here in a little bit. I don't want to be too aggressive with the sharp tools and take out the solder mask. Because if a trace gets cut or something like that as part of this cleaning process, it will be a nightmare to find. It'll be findable, but man, it'll be rough. The other thing with these latex bumpers like that, because these were those little pyramid things from the hardware store, that where it has a sticky back and it's like a foot. Depending on the composition, the latex ones, they can be stored well and they'll still do this. This isn't a improper storage problem, anything like that. This is just a time problem. Latex just does not withstand the test of time. Also, this unit is quite old. This unit dates to, I believe, the early 90s. And so that puts it at, at the recording of this video, over 30 years old. This is 2024, if I did the math right. So that's an incredibly long time for latex. All right, this looks amazingly better already. I got to deal with this back edge because this back edge is very bad, as well as up here in this corner. But I think we're getting close to being able to turn it back on, see if our DC offset problem goes away. An absolute pile of Q-tips and rags later, we are cleaned up. Here's what the bottom side looks like. That cleaned up real well. Doing this rail was kind of tricky, not getting any of that crap into this connector, but then also being careful of this toroidal transformer that's kind of hanging out in the middle of nowhere. And this plug right here is the main power transformer, which we're going to have to hook up once I get the board slotted back in. But I'm going to throw the bottom back on, put the power supply back together, and see what we do. All right, after waiting a while for the alcohol to flash off and get everything all set, let's see if we did some damage. Well, that's a good sign. All right, we do get our error 193, so let's see if it's a warm-up problem especially with how much junk we removed and how intrusive we were to this unit, it could very easily need to warm up a little bit and might need some minor adjustment. So let's put the top cover back on and let's give it some time to warm up and see if it won't do a manual calibration. Okay, well, it's not a warm-up problem, and I now know what's going on with this thing. And the question now is, how the heck am I going to fix this? What we've got is we've got a unit that will pass calibration. So if I hit manual calibration right now, it'll pass. No error, 193. Everything's good. Anywhere from 1 volt to 4.5 volts. The test conditions are a frequency of 1 kilohertz, amplitude of 1 volt peak to peak, 0 phase shift, and a DC offset of 1 volt. So if I give it enough DC offset, it'll actually shoot out and align, and it'll actually be very good. If we take a look at the meter, we're at 4. It's bouncing at the 4th digit, which is what this thing's supposed to do. Well in specification. That's good. Channel B is also the same. Same setup, 1 kilohertz, 1 volt peak to peak with a 1 volt of DC offset. And if I do a negative 1 volt DC offset, it'll kick over negative and it'll be at accuracy. It's plus minus 75 millivolts. So the unit is actually calibrating and aligning exactly the way it's supposed to. The problem is if I go below 1 volt, so let's say 0.5 volts. Now I still got 1 volt offset on channel A. This is a 0.5 volt offset on channel B, or a negative 0.5 volt offset, and that aligned just fine. So we can go down to negative 0.1. And that aligned just fine. If I go to 0, it'll error. So the problem is on our positive DC offset setting, if I go to 0.1, it won't align. Error 193. Go back to negative 0.1. Gives us 193. We dial up. If I go to 1 volt, it'll stop erroring. And it makes a liar out of me. There we go. So, what we have is we actually have a relay contact resistance problem. It's not aligning because it doesn't have enough signal getting through some of the switching relays. When you hit this manual calibration button, a bunch of relays in this thing go kind of nuts. And it routes signals all kinds of places. There's a couple of relays, especially at the small signal side, that the contact resistance has gone high and it's not getting through correctly anymore. That's why when we do it at 1 volt, it works, but if I do it at half a volt, it dies. 4.5 volts, no problem, plenty of signal, everything gets, or you make a liar out of me. Yeah, it was channel A that was doing it. So, I am guessing we either need to do a full alignment, check the reference, do a couple other things, or we need to put some relays in this particular unit. But we have made vast improvements because it is actually got a brain, and it's 98% there. And one other thing to add is it will do a 0 volt offset without a problem. It just won't calibrate a 0 volt offset. So this is what's leading me to believe it is some of the small signal relays in this particular unit. Okay, in an effort to try to find this DC offset problem, I pulled out the A36 board, which has the calibrator, the reference, and a bunch of other stuff on it. So we have the calibrator section, references up here, and we have some analog switching, input switching right here, and I am very curious as to these relays. Some of these relays are known to be a problem, so let's take a look at those on the DMM. Okay, so here's our relays in question, and we have a 8-pin combination, 3 contacts in the coil, 2 poles on each relay. Coil's off to the right. In this case, it's the pins furthest away from the line. The line denotes the normal open, normal close. Center 2 are the normally closed. Outside 2 are the normally open. So we're going to check the normally closed relay contacts for dead shorts. I'm looking for below an ohm, kind of really low contact resistance on these relays, especially given that our fault is around a volt, things like that. Too much resistance in the relay is going to throw it off. And short the leads out. Well, that was a crappy connection. There you go, 0.9 or 0.09. 0.3. Yeah, 0.097 is my contact resistance when I get a really good contact on the meter leads. So first relay, open, normally closed. Oh, that doesn't look good. 1, 2 ohms. Next pole on this first relay. That doesn't look healthy. Second relay, there we go, 0.09. So that's a healthy relay. Second pole, 0.9, that's healthy. K4, 0.09, that's healthy. And 0.09, that's healthy. So I really have a question with K5. I've got some concerns. So let's pull that relay out and see what it's doing. Okay, with the relay removed, we'll check the normally closed contacts again. That doesn't look healthy. Like at all. 1, 2, 2 ohms, that's not healthy. Other side, 1.52. So this relay has got some problems. Well, I don't want to say this is the problem, but it is definitely a problem. I'm going to have to go see if I can find one of these and source this part. And we'll get some in and see if we don't make some improvements. All right, I've pulled the cover off this relay, which is usually a bad idea to leave this in circuit, but I did get the contacts cleaned up, and I got the contact resistance back down to 0.1 ohm, so a little bit over that 0.09 that it was before. So what we're going to do is we're going to put this back in, see if our DC offset problem goes away. If it does, we'll know for sure it's this K5 relay, and we'll get some parts on order. But this will let us check the troubleshooting and validate the logic. This particular unit's going to stay in the lab and be under my care if it ends up getting repaired. So it won't be a problem to crack it open and throw a new relay in here once the parts come in. So let me get this put back in the unit and we'll see what happens. Okay, let's see if we still get a 193. That's a good sign. The processor's starting up. Okay, so we did get our still error. Let's see if we made any improvements and we're right about that relay, or if we did a bunch of work for nothing. So we'll set it to a 1 volt amplitude, DC offset of 0 volts. Channel B, 1 volt amplitude, DC offset of 0. Now this was not calibrating prior. Anything more than like a volt of offset, and it would 193 all the time. So 1 kilohertz, 1 volt, no DC offset, and no phase shift. We got a 193. Let's add some voltage. Okay, so it is now happy at a 0 volt DC offset. So our K5 relay on the reference board and calibrator board has improved the situation. But this means we have more relays that we have to go find, because if I drop the amplitude on channel B, it passed then. And on channel A, if it's, let's check 1.5 volts. No. 2 volts, which calibrated before. No, which means it's a channel B problem. Except now it's not happy at all, and it was before. So what's it actually doing? Okay, so after playing around with some and running the self-cal a bunch of times, just trying to figure out kind of where the problem is, messing around with some parameters, because it doesn't really tell us much. On channel A, we have 1 kilohertz, amplitude of 0.1 volts peak to peak, no phase, and no DC offset. And we can calibrate it, and we get an error, which we didn't the last time I calibrated it, so it's still drifting around a little bit. Channel B, let's see if this works. Okay, let's try this again. So channel A, after hitting instrument preset, 1 kilohertz, amplitude 0.1, DC offset is 0. Manual align. Everything's happy. So I think our problem right now is actually channel B. So I'm going to have to dive into channel B and take a look at for some more relays, find out the next one that's bad. Because if I bring the DC offset on channel B down, it's going to fail. It's not. It's going to make a liar out of me. Now it will. Okay, so it's the low range. So 1 volt on channel B, 0 DC offset, and then it errors out again. So channel B is definitely the problem, because if I take this back to 1 volt with 4.5 volts of DC offset, it's going to go just fine. Yeah, it doesn't care. So I have another relay with bad contact resistance, and we will need to find that. But everything's narrowing in. I think I'm going to call this video here for right now. This thing has been some trouble. We'll call this part 1, and we will be back with part 2. I really, really want to get this thing fixed, and it's spent enough time on the bench where it is going to get fixed, whether it likes it or not. So we will get this one up and going. So with that, I hope you guys enjoyed and got some value out of going through the troubleshooting process on this. We're going to hit this again, find that last relay, go from there. I just have to take a boatload of screws out of here and check all these modules for relays and see what we may want to... I'll probably cut it apart and clean it just to make sure, but then we'll get some real replacements in here. As always, a huge thank you to the patrons that assist me in bringing videos to YouTube. Their help is greatly appreciated, and they help way more than anybody knows. As always, if you guys would like to support the channel, help me get videos out to YouTube, check out the Patreon page. There are a bunch of early access videos before they hit YouTube, and see what we got coming, and additional content. There is currently nothing behind the paywall, so anybody that assists on the Patreon page is helping directly just bring videos to YouTube and helping get more information out into the wild. As always, I'll be in the comment section in between videos, and More is always on the way.